Did I click select folder or did it just drop it? Is it recording?
Yes.
Are we sure it's recording inside of the desktop right now?
No, it's recording it.
Is everyone here today? No, we're missing people. Great. All right, there. And it doesn't matter. Here we go. Ready? Okay. Journal's out. You guys ready? Ashlyn, ready? Ready, spaghetti? Does anyone say that anymore? Or is that a thing of past? Ready, spaghetti? I think that was on a TV show when I used to watch as a kid. Are you ready, spaghetti? I'm ready. No, that's SpongeBob. I'm ready. Isn't that what SpongeBob says? Okay. Yesterday we learned a lot of different distributive properties. Today we're going to learn the distributive property at the very first. Now most of you should be extremely familiar with the distributive property, right? The distributive property is when you have something on the outside of a set of parentheses. All you're going to do is you're going to distribute it to what's on the inside, right? And when you distribute something to inside of parentheses, you do what to it? What do we do with this 3? We bring it in and we do what to that x? We times it. So 3 times x is 3x. 3 times negative 1 is negative 3, right? And it goes to everything inside of that set of parentheses. It doesn't matter what's in there. It goes to everything inside of that parentheses, right? And sometimes you have to pay really close attention to what's on the outside. So if I had something like this, you have to pay very close attention that, wow, why didn't someone see you, Mr. Glazier? You're writing like a 90-degree angle. Okay? So if you have something like this, you have to pay very close attention to this number on the outside, because if it's a negative, you got to make sure when you're distributing that through, that you make sure you're distributing that negative through with it, because that's going to make negative 6r, negative 18g, and positive 6t, right? Hopefully you guys are all really familiar with the distributive property. Now this thing can look a little bit different, right? We may see something like, how do I want to write this? We may see something like 2 times y minus 1 plus 6y. We may see something like that, where it's a distributive property plus a little something extra. So I call this, like when problems start to add like something extra, it's like getting little sprinkles on your sundae, right? It's just something a little extra, something to make you think a little bit harder. Do I want sprinkles? Maybe I do. Okay, so first thing is, we're going to distribute that 2 through. Hopefully, like I said, we should know how to distribute it. You guys have been learning it for a couple of years. But then we have 6y out here still. Now that problem's not done. It's not simplified. Someone raise their hand and tell me why that problem's not simplified. Everyone raise your hand if you know why that problem's not simplified, if you know why. But what do we got to do?
The 2y, or no, you have 2y and 6y.
Why?
Because they're of the same table of y.
Okay, so they're both y's. What's the name for this?
Like terms?
Yep, we're going to combine together like terms. Things that are the same, you have to combine together to be able to get the finished product. So 2y and 6y make 8y to be able to get the finished product. Right, Dom?
Yep.
Okay, so if we had something like this, though, here, this is a hard one. So if we had 2, I literally wrote 4 and said 2. It's going to be a long day. xy plus 3x plus 5x. So if we had something like that, first thing is, anytime you're given the option to distribute, you should always distribute, right? Distributing is the first step to be able to simplify a problem. So we're going to distribute this to this. What is 4 times xy? 4xy. What's 4 times 3x? 12x. And then you just have 5x out here. Now pay attention. I noticed when I've done this before, people think that 4 goes to that 5. Why does that 4 not go to that 5, Anna? Can you tell me?
Because they are different. What's it called?
So why do we not multiply 4 to this 5?
Because it's not in the parentheses.
There we go. It's not inside of the parentheses, right? So good. Now look at this problem right here. Can we combine 4xy and 12x? Why? They're not like terms, right? This one has a y, this one doesn't. But we can combine 12x and 5x, correct? So our solution would be that, correct? Okay, that's it. That's it on that first section. Any questions on that? I just did a whole section. How long did it take me?
5 minutes, 30.
You're kidding. Look at this. Look, hey, here we go. You guys ready? All right, everyone take a breather. All right, we're good. Shortest breath ever. My eyes are hurting. Give me a second. Let's just do it blinded. I wonder if I could teach a lesson not even seeing what I'm teaching. Here, we're going to try. You ready? I don't have a tie. I was going to tie a tie. Okay. So that was section 1.4. Section 1.5 is called equations. And we're not going to start solving for x yet. That happens in chapter 2. What section 1.5 says is this. So inside of your journal, I just want one problem written down. You're going to title it equations. And what they're going to do is they're going to give you a set of like an equation like this. So they'll say 2q plus 5 equals 13. And hopefully everyone in this class right now can look at that and can solve for q. I hope that you can. We need to be able to do, I need you to be able to do that before we get there. But we're not going to do that right now. That'll happen in chapter 2. What we are going to do is they're going to give you a set of numbers. So what they're going to say is, here's your set of numbers. So 2, 3, 4, 5, and 6. And they're going to call them a replacement set. So this is called, and I'm not too sure what Alex calls them. They're called a replacement set, but sometimes Alex says things and I'm like, come on Alex, that ain't real. Okay, I'm going to call it a replacement set. Hopefully that makes sense to at least a part of you. The replacement set, what we're going to do is they give you 5 different numbers here inside of the replacement set. What we're going to do is we're going to plug in every replacement set into this equation like this. And we're going to see if it makes it true or not. Now look, I'm telling you, when I teach non-honors, I'm going to teach it like this. You guys are honors, right? I'm going to, hopefully everyone can look at this. What's the answer to this problem? 4, right? So when I plug in 2, is that going to work? No, right? I'm going to get 9 equals 13. Does that work? No. So Alex is going to ask you to plug in every one of these. And they're going to say, plug them in and see which one works. Please don't do that. Okay? I'm teaching it to you like Alex and the state and the big ups want me to teach it to you. But now I'm going to tell you, I'm not even going to finish. I'm going to tell you, look at it. If you know the answer, do it. If you don't know the answer, great. Plug in each one of these in for Q and figure out which one of them works. Because as soon as you would have plugged in 4, you would have found that it works, right? Does that make sense? Okay, give me just a second. I'm going to look at Alex real quick and just see exactly what they ask, what they call it. Mouse coming. Nope, not there yet. See that? One day, mouse here. Oh, jumps to my hand. Haley's going to fall over a chair because Mr. Glazer just trying to move something in his mind. There's going to be people crying. Britain's going to be like, what the heck just barely happened? You seriously just going to move something in your mind? And I'm like, dude, it's been happening for a while. Till that day happens, though, I don't know exactly what we're doing. Till I can start to move things with my mind, what are we doing with this life? We're not doing what's right. We need to start moving crap with our mind. Okay, hold on, give me just 2 seconds. Here, I got an idea today. When I assign out homework, we're going to play a game to determine how many problems I assign.
Oh, right.
It ends up being really fun. Okay, hold on. We got to look at a couple problems. So Alex says it like this. Alex says, identifying solutions of one-step linear equations. Hold on, let me see what it looks like. So yeah, so Alex says it the exact same. Here, can you guys see that at all, or is that terrible? So what it says is this. Here, look up here. So just to show you, it says u minus 39 equals 9, and then it gives you a set of numbers. And all you're going to say is this a solution? Yes or no? Is this a solution? Yes or no? You guys can solve this and figure out that U is 48, right? You guys can click yes here and then quickly just click no on the others. I wouldn't go through and I wouldn't, it's the exact same thing. I would not go and spend time plugging each one of them in unless you need to. If you need to, that's great, do it. But if you don't, solve the equation. Let me look at this one. Did it bring it over there? Hold on. What happened here? There it is. Hold on. So, and then it's going to give you, okay, this is the other thing I wanted to see, and this is what I was happy to see. The next thing they're going to say is this. Look up here. And this is the one thing you will need to do. But I'm going to show you one of these problems, then we're going to get to homework, okay? So they're going to give you an equation like y equals 6x minus 3. And then they're going to have a table like this set up. And they're going to say, and they're going to give you x values. They're going to say like x equals negative 1, 0, 1, 2, and 326. Right? Not really, but they're going to give you x values, and they're going to ask for you to plug in the x to get a y value in return. So for example, on this top one, where x equals negative 1, you're going to plug negative 1 in for x and solve to get y, which is negative 9. On this one, you're going to plug 0 in for x, and you're going to get negative 3. This one, you're going to plug 1 in for x, and you're going to get 3. This one, you're going to plug 2 in for x, and you're going to get 9. Anybody else see a pattern happening here? Kind of cool, right? What's up, boss? This one right here, you're going to plug in 6 to 326, and Mr. Wheeler's here, so we're going to have him do that in his head. 326 times 6. 1916. Help me out. Someone help me out. Who's got a calculator out? 326 times 6. 1916 is my question. Who's got a calculator? 1956. Drilled it. 1956 minus 3, so 1953. That seems like an important year. Something happened in 1953. Yeah. Okay, that's it. You need me?
How dare you interrupt my SOI test from doing
Well, how did I do that?
got on the intercom.
Oh.
Have a kid come, like, do a little bit. Why is every sign? I'm like, come on.
I waited for the last like 4 minutes. Tried to wait. Wasn't waiting enough.
Did you see my text?
I haven't seen it. I just got one. I just grabbed it. Was it a mean one?
Yeah. I'm not looking at it then. I don't say shut up or something.
Yeah, I know. I deserve it too. I gave them my spill. Well, all right, we're going to let them pick the number of problems today. By that, I mean we're going to ask them a series of questions to determine how many homework problems they get. So, let me pause this thing.
Wait, do we have less problems possibly?
So here's your option. I'm going to ask everyone in this class. Hear me out. Where the heck's the mouse? Does anyone see the mouse?